Hi, I'm learning computer graphics, and I'm making a series of videos based on what I'm learning. In this first video, we're going to learn how to open a graphical window like the one you see on the screen. And in the future videos, we'll learn how to draw stuff on it and then move to algorithms for drawing lines and triangles. And later we learn how to take a 3D scene and turn it into a bunch of triangles for rendering. And if you know the basics of C programming, you should be able to follow along. And the series is cross-platform, so you can follow on any operating system. But I'm on Windows, so I'm going to spend the first half of this first video setting up a minimal C++ project using Visual Studio and adding SDL to it. And as SDL is a cross-platform library for graphics that we're going to use for opening windows and drawing stuff onto them. So if you're on a different operating system, then just learn how to set up a C++ project in your system and add SDL to it, and then you can jump to the second half of this video. And in the second half of the video, we write the code that opens a graphical window. Okay, so let's get started setting up a project on Windows. Before you start, you should have Visual Studio with a C++ workload installed on your machine. If you don't, go install it. Just remember that during installation, you should check either desktop development with C++ or game development with C++, or both checked. Otherwise, you don't get MSVC, which is Microsoft's Visual C++ compiler that we need for development. Now, first, I'm going to create a solution and project for our application. If you don't know, a solution is a container for one or more projects, which is useful when you have an application that grows very big and you want to split it into parts. So I'm going to select Windows Desktop Wizard and pick a name for the solution and on the project. And in the dropdown, I'm going to select desktop application. Console application works too. The only problem is that every time you run the program, you'll get a terminal window opened as well, which is kind of annoying. And I'm selecting empty project. And here, our solution and project are created. Now let's download SDL and add it to our project. Go to SDL's website and press this button here. It opens up SDL's GitHub releases page. Now, if you scroll down to the bottom, there's a list of packages to download. I'm on Windows and I'm using Visual Studio's compiler, so I'm going to download SDL Devel VC. VC means Visual C++. It's the compiler that comes with Visual Studio. Now I will copy SDL files into our solution directory using the File Explorer. Just right-click on the solution and open it in the File Explorer. And here on the left is the contents of the SDL package that we downloaded. Now, first I'm going to make a directory inside our solutions directory called dependencies for external libraries like SDL. And inside it, we're going to create two folders. One of them is include for the header files. And the header files are just function signatures and other type definitions that the compiler uses for type checking our code. We also need to add another folder for the files that our linker needs. I call it lib. Now we have to copy three things from SDL into our project. The first one and the most important one is the DLL, which is inside this lib folder. And I'm on an x64 machine, so I select x64, and here's the DLL. And we should put the DLL next to our executable. But where is the executable going to be? Well, it depends on our target platform, for example, x64 like here, and whether we're building a release or a debug build. For example, right now, debug and x64 are selected. Now if I go and build my project, I can press just F7. Now if I go back to my solutions directory, you see that a new folder x64 has been created. And inside that there is a folder debug, which is currently empty because we have written no code. But in the future, our executable is going to be here. And as I said, the DLL should be next to it. So I just copy the DLL here. Maybe in the future we do some release build, and then we also have to copy the DLL into that folder. But for now, that would do. The next thing that we have to copy is this SDL3.lib. Our code should be linked against this lib file, the import library, so that the resulting executable knows that the actual code for SDL functions are in the DLL. And since our code needs to be linked against this, it should go where our linker files or our library files are going to be, which is in dependencies lib. Now, the last thing to copy is just the header files for SDL, and they're inside this include folder. And you see here, there's another folder, SDL3. Inside it, there are all sorts of header files. This SDL.h is the main one that we have to include in our code later, and it will pull in all the other header files for us. So we copy it into our include directory that we created previously. And that's it. We have copied everything that we should have copied. And now the DLL, as we said before, is just next to the executable, and at runtime, Windows is going to load it automatically and run it. So there's nothing to be done there, but we need to tell our compiler and the linker about this include and lib folders that we added. And let's start with this SDL3.lib. Let's tell the linker to link our code against it. To do that, we go to our project's properties and open up the linker and select input. And here we can add dependencies. I'm going to add that SDL3.lib. And the semicolon here is just to separate it from the other dependencies. Now, we added SDL3.lib as a dependency, but the linker is not going to find it because the linker is going to search some default directories for lib files, and the lib directory that we created is not one of them. So we have to go tell the linker that to search it. So click on General, and here, additional library directories. Here, we type the address of our lib directory. And this solution dir just expands to the address of the solution directory, and it also has a backslash itself, so we don't need to put a backslash here between the dependencies and the solution dir. So the linker is done. Now, and just like we told the linker where to find our lib files, we need to tell the compiler where to find our header files. But here on the right, currently we don't have any section for compiler options. And the reason is that Visual Studio does not know that our project needs C++ compiler options. To fix that, we just close this properties window, create a CPP file in our project, and reopen the properties window. So I'm going to create a CPP file here. Let's call it main. And it can be empty, doesn't matter. And now you see an option for the compiler has been added. We have to put the address of our include directory here. Okay, so now we can start coding. Inside our main.cpp, I'm going to write the entry point of our program. Now, normally the entry point of a C program is main, but on Windows, the entry point of a desktop application is win main. Writing a win main function is kind of verbose, and it's not really necessary because SDL gives us a simpler option. We can write a simple normal main function, and SDL has some redefinition macros that turn that into a win main function. So I'm just going to write a normal main. These parameters, we normally can remove them, but the SDL redefinition macros expect them because they work with this exact same signature. So we need to keep them. And now let's include the macros, SDL macros for redefining main. And this address here is relative to our include directory. Now, if everything is set up properly, then if you press F5 and run a program, it should build and run successfully and exit with code 0. Now, let's get started. First, we're going to include SDL's header file. The header file that we have included already is just for redefining main to win main. Now, before we can start using SDL, we need to initialize it with a function SDL init. But SDL is a big library and it has many subsystems. We have to choose which subsystems we want to initialize by passing the right flags. For opening a window, we need to initialize the video subsystem. And the flag for that is SDL init video. So now, if you don't know what a flag is not a data type. In fact, this function SDL init just takes a uint32, an unsigned integer of 32 bits. And this SDL init video is just such a number. What makes it a flag is how it's being used by SDL. When you pass a number to SDL init, it's not going to do any arithmetic on it. It's going to look at the representation of that, the 32-bit representation of that, the zeros and ones, and decide which subsystems to initialize or not based on that bit array. For example, let's assume that the 10th bit determines if the video subsystem should be initialized or not. Now, if it is a 1, then it gets initialized. If not, then not. Now, I'm not going to explain this anymore because it's not related to our goal, but if you're interested, go search for flags and bitwise operators. Now, SDL initialization might fail. I've never had that experience myself, but I'm going to check in case it might fail on your computer and you'll want to have some error messages to know what to do. So this function returns true on success, and otherwise it returns false. So I'm going to print some error message when it fails and then quit. Now, most of this is obvious. Just note that SDL get error returns a message about the last error that has occurred. And here I'm using SDL log instead of printf or cout because this is a desktop application and we don't have a standard output to print to. So printf or cout would print nothing. And SDL log instead prints to the debugger. And we can see its errors. We can see the error in the output window. For example, let's print hello to see how it works. If I run this, in the output window, I'll have hi here printed. Now, before we move on, I wanted to show you how you can find more information about different SDL functions. Our focus here is not on SDL, but still you might forget some detail about some of the functions and want to check it out quickly without watching a video again. So SDL has this wiki page, which is its official documentation. And here there are all sorts of stuff, examples, tutorials. But if you want to check the documentation for a specific function, just click search and then type the name of a function. For example, SDL init. And if you scroll down, you see that SDL3, SDL init is here. If you scroll even more, you see that there is another SDL init here. The difference is that this entry is for SDL2, and we're using SDL3, which is the current version. And here you can see the list of parameters, the return value, and we scroll down even more. You see here we have the list of flags that we can pass to initialize different subsystems. So back to coding. Okay, now we're ready to create a window. To do that, we use a function called SDL create window. It takes 4 arguments: the title of the window, width and height. Title can be title. And the last one is for flags. For example, if we want to make the window resizable or full screen, we pass the right flags here. We don't want any of that, so we pass 0. And this function is going to return a pointer to an SDL window. So if SDL create window fails, this pointer is going to be null. So in a real application, you want to check for that. But here I don't, because I want to keep the code readable. And a side note, this SDL window is an opaque struct. It means that we don't know its internals by design. So its implementation might even change the next time they update SDL. So for example, if you want to know the window size, you can't just go and access its members. Instead, you use the functions that SDL provides. For example, if you want to get its size, you write a function like this. And then pass the pointer, something like that. Okay, now our window is created. But to draw something onto the window, we need to do some setup on the GPU side as well. For example, frame buffers need to get created. And a frame buffer is just a block of memory that stores the color of the pixels. And shaders need to get created. Now, a bundle of this shader, frame buffer, and all the other things that are needed for drawing is called a rendering context. So we need to create a rendering context to be able to draw something onto a window. And for that, we use a function called SDL create renderer. They probably chose this name to keep it short. Now, the first argument is the window pointer. And the second argument we don't need, so we just pass null. And this function, of course, returns a pointer to an SDL renderer. Now, anytime we want to do something with our window, for example, we want to know where it is on the screen, or whether it's minimized or maximized, or do something like that, we pass the window pointer to SDL. But anytime we want to draw something onto it, or for example, put an image onto our window, then we use this renderer. Right now, our program will create a window and then quit immediately. But we want it to stay open, and not just stay open, but keep listening. So when the user presses some button, it notices and updates the screen, just like Visual Studio here. For that, we're going to create a loop that is going to process or handle the user input and then update the screen. Now I use the while loop here, and this variable running, I'm going to define it in a second, is going to control when we quit. Now at first we set it to true, so this loop keeps running. And then when we want to quit, we set it to false and we exit the while loop and then the program. Okay, now let's talk about this handling the input, or more generally handling events. An event is anything like a user input, like a key press or mouse motion, but also things like when the user presses the X button to close the program or resizes the window. When an event happens, SDL adds it to a queue called the event queue. And during event handling, we're going to remove these events from the queue one by one, do whatever we need to do until the queue gets empty. And then we go and start updating the screen. And now let's say that by the time that we're done updating our screen, 10 more events happen. Then next loop, we have 10 more events to handle. We handle them, and this keeps running again and again. Now, to get an event from the queue, we use a function called SDL pull event. It takes just one argument, the address of an SDL event variable. So I'm going to create a variable of type SDL event and pass its address to this function. Now, anytime we call this function, it's going to remove one item, one event from the queue and puts its information in this event variable. But as I said, during event handling, we're going to handle all the events that are currently in the queue. So we need a loop to handle all the events. I'm going to write the loop and then I explain it. When there are events in the queue, SDL pull event removes the first one, puts its information in the variable, and returns true. So as long as there are events in the queue, this while loop keeps running until the queue gets empty, and then SDL pull event returns false and we get out of event handling. That's how it works. And for now, the only event that we care about is quitting. So for example, when the user presses the X button or Alt F4, a quit event is put on in the queue. And to check if an event is a quit event, we just check its type. Now, let's move to updating the screen. Now, this session, we're not going to draw anything, so I just leave a comment here, says draw for later. But before drawing, we need to clear the screen to make sure that there's nothing left from the previous frames. And to do that, we use a function called render clear. And we just pass the renderer. By default, this is going to clear the screen to black, but I want to make it green. So to do that, we need to set the renderer's draw color. The draw color is the color that the renderer uses for drawing primitives like lines or triangles, or when it wants to clear the screen. And we're going to set it here right after creating our renderer. And to set it, we use a function called SDL set render draw color. Of course, the first argument is again the renderer. And then there are 4 more arguments, 3 8-bit values for red, green, and blue. I want it to be green, so I pass 0 for red and blue. And the last one is alpha, which controls the opacity. 0 means totally transparent, and 255 is which is the maximum, means fully opaque. And because I want to clear the screen, I pass 255. Now it seems that drawing should be over. But there is one more step to do. When we call the drawing functions, SDL is not going to draw onto the same frame buffer that a monitor is reading from. And if you remember, a frame buffer is just a block of memory that has the color of the pixels. It's going to draw onto another buffer. I'm going to explain why in a minute, but the point is that after we're finished drawing, we have to tell SDL to put this other buffer on the screen. And for that, we use a function called render present. Now, the reason SDL draws onto another frame buffer is to prevent visual artifacts. For example, tearing, like this image here. And that happens when you have moving objects in your scene. But even if you have your scene is totally static and nothing moves, you still need multiple frame buffers to prevent visual artifacts. The reason is that drawing is not done by going pixel by pixel and determining the final color of each pixel. Usually what you do is that you update the screen by drawing possibly overlapping elements. For example, you draw some background, some mountains in the background, and then you put the character on top of that. So if you were drawing onto the same frame buffer that the monitor is constantly reading from, many of the pixels will be in this intermediate state. They don't have their final color. So you'll end up having artifacts. Now, if we run it, we should have the green screen. So that's it. Next episode, we're going to see how we can change the color of each pixel separately. Bye.